Here is an application problem to find minimum distance between the boats. The question is, a boat leaves a dock at noon and heads west at speed of 25 kilometers per hour. Another boat heads north at 20 kilometers per hour and reaches the same dock at 1 p.m. When were the boats closest to each other? Now, to do any word problem, we need to sketch and then figure out how to form an equation so that we can simplify the equation or solve the equation to get the answer. So let's consider coordinate plane here. Since the two boats are at right angles, that is a good starting point. Now it says a boat leaves the dock at noon, that means 12. So we know, let us say, what is the situation at 12? At 12, boat A is right there at the dock, and that is our original point. We'll call this point as O, right? So this is the dock at 12. A boat is at this point. Now it heads west at a speed of 25 kilometers per hour. That means it is heading in this direction. As the time goes by, the distance of this boat increases at the rate of 25 kilometers per hour. So we can write this distance as 25t, right? So with time it is increasing at this constant rate of 25 kilometers per hour. Now let's consider the other boat. Another boat heads north at 20 kilometers per hour and reaches the same dock at 1 p.m. So if it reaches at 1 p.m., that means it reaches after an hour. And since the boat is heading north at 20 kilometers per hour, in an hour it can cover 20 kilometers, right? That means at 12 noon, this boat must have been 20 kilometers away, right? So it is heading from here. Now from here, if it heads, let us say in time t, it covers some distance. So this distance covered by the boat will be 20t, correct? Since it is heading at a constant rate of 20 kilometers an hour. And now, at any instance time, the distance between the two boats is going to be this diagonal distance. So let me connect that. So that is the diagonal distance. It is a diagonal since these two boats are heading or moving away, or at times you can call them approaching, but there has to be a minimum distance in between, and then the distance increases at right angles in any case, right? So that is the kind of situation we have. Now from here we need to find an equation which should represent the distance between the two boats, right? That distance. So let us say that this distance is s. Now how to relate s with these two distances? So we can say x is, let us say this is the value x here and y here, correct? Now what is x equals to? Let's figure that out. Now in this diagram we know x is going to be 25t, right? And what is y going to be? Y is going to be, this distance is 20 here, right? So let's forget about minus 20. I know it is, you'll say coordinate plane minus, but think about distance at present. So it is 20 away from 0, but with time this distance decreases by 20t. So we could always say this distance is 20 minus 20t, correct? Let us say time is an hour, it will cover 20 and so it will be 0, right? Now you'll get into problem if t is greater than 1, it seems to be negative, right? But for the time being, let us consider the triangle and let us consider that our limits are from 0 to 1 hour, okay? Now you'll soon realize that doesn't really make difference because distance is square of these. So even if this number shows negative here, when you square it, it will be positive, okay? Anyway, as you can see, this triangle is concerned, y will be equals to 20 minus 20t, correct? So that is x and y. So we can write here the equation now. S equals to, you can say s square, or we can say s equals to square root of x square plus y square. Now x square is 25t, so we'll write this 25t whole square plus y is 20 minus 20t whole square, square root, correct? Now that ambiguity, if time is more than an hour, this y will be represented kind of negative. So to solve this, let me say distances are always positive and put an absolute value here, okay? So that solves the purpose, correct? So I think that should be a good solution. So that becomes the distance between the two boats at any instance of time, okay? Now, other way of looking at it is that it is square, right? Therefore, it will be positive. Now, come on. Let's do a derivative of this separation between the two boats with time. So we have ds dt will be equals to half of the square root, everything in the square root to the power of minus half. So I can straight away write in the denominator, right? So let me just put it in the denominator. That is this whole thing to the power of minus half. We get 25t whole square plus 20 minus 20t whole square. And then derivative of inside term. So derivative of this is 2 times 25t times derivative of inside term. So just chain rule. Or you can say power function rule also. Plus this derivative will be 2 times 20 minus 20t. Derivative of this will be minus 20, correct? So that is what we get. Now this could be simplified. We can cross out this 2 with these 2's, right? Now we have 25 times 25 is 625, so you can write 625t, and 20 times minus 20 is minus 400, and this is minus and minus makes it positive 400t over square root of all this, right? So this is 25t whole square plus 20 minus 20t whole square, square root. Correct? So let me write square root. We can further combine these two terms, and we get 1025t minus 400 over the square root of all this, which is 25t whole square plus 20 minus 20t whole square, square root. So that is ds dt. Now to find a critical point, ds dt should be 0, right? So the critical point will be at, so let's say critical point. That means this is equal to 0, right? That is the point when this is equal to 0. Now we'll solve for critical point on the right side. So we can say that for critical point, 1025t minus 400 equals to 0, right? So that gives us a value of t, and we can say t is equals to 400 over 1025. And that is, let's use the calculator. So we get 400 divided by 1025. It gives me 16 over 41, which is 0.39. So 0.39 is our critical point. Now we need to analyze this critical point to figure out whether this really represents a minimum or not. It could represent minimum, it could represent maximum also, or neither of the two. So how do you figure out that this is a minimum or maximum? Well, one way is that you check the rate of change on either side of this critical point. So we have this critical point right here, which is 0.39, right? So now if I substitute a value which is less than 0.39 in this equation, that means if I put t as, let me use another ink, if I use t as less than 0.39, then you can see this number will be less than 400, right? Because for 0.39 it is 0. In that case, s dash is going to be negative, right? Is going to be less than 0. That means negative. That means going downwards. Now if t is greater than 0.39, in that case, separation between the two boats is going to be greater than 0. And we know it is 0 at this point, correct? So as you can see from here, we do have a minimum at our critical point, right? So we have a minimum at t equals to 0.39, and as far as the unit goes, this is 0.39 hours. Now the question is, when were the boats closest to each other? We have to give time. So let's convert this hours to minutes. So 0.39 hours times 60 will give us minutes. Is that okay? So that will give us time in minutes. So 60 into 0.39, let's do, times 60, we get close to 24, right? 23.41. So we'll just write 23, okay. So we'll write 23 minutes. Therefore, the time when they are closest will be, so the time will be 12 plus 23, that means 12:23 p.m. So at 12:23 p.m. the boats will be closest. So that is our answer. So our answer is boats will be closest at 12:23 p.m. Correct? So that is how we can solve this question. Let's have a look at this particular problem once again. So when you have a word problem, it's a good practice to kind of make a sketch and then find relation between what we want to find. Here we wanted to find closest distance, that means the separation between the two. So we defined a variable. Let S be the separation at any instance of time between the boats. So that's a variable. Now to relate the two, we know we'll add 12 noon. So the situation we start at 12 noon. So we say let time be t after 12 noon, right? So after 12 noon, one boat heads west. So the distance increases at the rate of 25t. So along this, if we make a triangle, the separation will be 25t. And on the other side, since the boat reached this point after an hour, it must have been 20 away. And the distance is decreasing by 20t. So we get the other equation as 20 minus 20t. Now using Pythagorean theorem, we could relate these two. So we got the separation as square root of 25t square plus 20 minus 20t whole square. Now finding derivative, equating it to 0, getting the critical point is the next part of the question or the solution. And the third part is to really ensure that this is a minimum, which we did by testing time just before and after the critical point. And we did realize that before the rate of change was decreasing and then it was increasing. That shows at the critical point we have a minimum. Now that was in hours, so we converted that to minutes to find the real time. So the time was 12:23 p.m. So that is how we can solve this. I hope it's absolutely clear. Thank you.